Hi everyone. I hope you've watched the review for statistical inference for one proportion. In that video we gave a reminder of our outline for confidence intervals and hypothesis test when we have a question about the proportion of a population. In this video we're going to repeat all those steps, but now we're interested in comparing the proportion for two different populations. So you'll see a lot of similarities here. So when we're talking about two different proportions, we're going to be using the notation P1 for the proportion of the first population and P2 for the proportion of the second population. There's lots of circumstances where you might be interested in comparing proportions for two different populations. For example, right now we're nearing an election, so we might want to compare the proportion of voters for two different candidates. COVID-19 is going on. Maybe we're interested in comparing the proportion of smokers and non-smokers that have different end outcomes when they're exposed to the virus. Or maybe we're interested in comparing the proportion of outcomes for younger folks and older folks, and the ideas can go on. So lots of different settings. Think of topics you're interested in, your own field. You're often interested in comparing proportions for two different groups. Now I've written here this is the difference in proportions. This is informative to look at for a few different reasons. So, for example, suppose I calculate this difference and I get a positive number. If I get a positive number, then that's telling me the first group was bigger. I'm doing bigger minus smaller, I get a positive number, so the proportion for the first population is larger. First group larger. On the other hand, if I get a negative value, then that's telling me the second group was bigger. I've got a small minus a big number to give me negative, so negative values of this difference again tell me second group is larger. And then if I get a zero, if I just get 0 here, then that's telling me these guys are the same. I have no difference between the two populations. So here I'll say no difference. Group 1 and Group 2 are the same. All right, so in all of these, we're going to be communicating or looking at two proportions via their difference. So let's start with our familiar process of confidence intervals. So confidence intervals for two proportions, and specifically, we're going to be, again, talking about a confidence interval for their difference. All right, so remember from the last video, whenever we are talking about confidence intervals, your mind should immediately go to the three things we need every time. Point estimate, plus or minus our margin of error that has both of the other pieces. We had our multiplier that gives us our level of confidence, and our standard error that says, hey, if I take a different sample, I'm going to get a different point estimate. Let's take that variability into consideration. So putting this in the context of two proportions, if I want to estimate P1 minus P2, let's start with what we do have, the values from the data. So P1 hat minus P2 hat. So the difference in the data is going to be my initial estimate for the difference in the two groups for the population. Good thing for you, our multiplier is exactly the same as before from the normal distribution. And as a reminder, we found that Z star using inverse norm on our calculators. Go back and review that if you need to. And then our standard error describes the variability, how much these difference in the p hats is going to vary from sample to sample. If you remember, for one proportion, it looked kind of like this. P hat 1 minus p hat over n, all under the square root. Now I've got the same thing, but for two groups. So here, I'm just going to add the subscripts. I've got P1 hat N1, so this is the variability contributed by my first group. Under the same giant square root, I need to also add the variability contributed by the second group. So P2 hat, 1 minus P2 hat over N2. Again, all of this is under the same giant square root. So here's our confidence interval for two proportions. And you can again see it has the same setup as for one proportion. We've just expanded it. If we want to interpret this, going to be the same setup. We are whatever percent confident, and then this time be careful in your wording. The difference in proportions, not just one proportion, for the population is between blah and blah. Give your interval. Again, we'll do an example in a moment so you can see how all this works in practice. All right, let's move on to our framework for hypothesis testing for two proportions. If you remember in hypothesis testing, our first step, we need to state our hypotheses, our HO or initial assumption, and HA, our research question. So we are now talking about two different proportions. I'm going to use P to denote the population proportion. Do not put P hat here. And now I'm comparing two different groups. So I've got to have a P1 and a P2. And just like one proportion, I have different options here. I might have the research claim that the first proportion is smaller than the second. I could have the research claim that the first proportion is larger than the second. Or I might have the question, I don't know how they're different, I just think they're different. 1 and 2 aren't the same. So have the same three options as we did for one proportion. And then HO, hopefully you've guessed it, is that the two proportions are equal. We still have our equal to sign in here like we did previously. So start off assuming nothing's going on, the two groups are the same, versus one group is different from the other according to our research question. This is one way to write the hypotheses. You have another option if you want to write it in terms of P1 minus P2, more like the confidence interval above, so you could see how their results match. So P1 equaling P2 is the same thing as saying P1 minus P2 is 0. Think of just subtracting P2 from both sides. So write it either way, I don't care. P1 and P2 are the same, or you could say their difference is 0. HA, similar idea. You could say that P1 minus P2 is either less than 0, greater than 0, or somehow just different than 0. So that kind of goes back to what we were talking about at the top of the page. Their difference is negative, positive, or there is just some kind of difference. Okay, so again, either option, choose this set or this set. They're both communicating the same thing, just in slightly different notations. Okay, so there's our hypotheses. Next bit we need is our test statistic. So our test statistic, we remember our review from our general setup. We've got our point estimate minus the null hypothesis. So we're checking out how far is our data from the initial assumption, and we're standardizing that or scaling it by the expected variability or our standard error. All right, so this is still our kind of elaborate z-score, so I'll call it z-calc just like before. Our point estimate, we're talking about the difference in population proportions. So our point estimate is the difference in the proportions for the data. So that's our p hat part. Then we need to check out minus the null. So I'm going to write minus P1 minus P2. Now, if you check out the null hypothesis, what does it say? It says P1 minus P2 is 0. So the assumption under the null is that there is no difference. Those are the same. So you can just plug in a big 0 here, or don't even write anything here. That's fine. But I want to emphasize it's still following this concept. How far is the data from the null? So we've got our data, And in this case, our null is there is no difference. The two groups are the same. And then if you remember, for one proportion, our standard error, we plugged in P0, that null hypothesis. So up here, we had the standard error for two proportions, but our null hypothesis is that 1 and 2 are the same proportion. So if these guys are the same under the null, we can factor those out of both terms and as this common same proportion. So I'm going to write our standard error this way. P hat, I'm not going to put a subscript on it because the null says they don't behave like two different groups. They behave like the same group. So P hat, 1 minus P hat. I'll show you how to calculate that in just a minute. When we factor that out, check out up here. We have 1 over n1 left over and 1 over n2 left over when we factored out that common proportion in the two groups. So times 1 over n1 plus 1 over n2. And I just want to take a moment to say, how do we find this p hat, this common proportion? To find this p hat, so I'll say where p hat is going to be the number of successes in both groups. So we're just calculating one overall proportion instead of two separate ones. We're just lumping all the data together as one giant group. So I'll say number of successes in both groups. And then it's going to be out of our total sample size in both groups. So n1 plus n2. And sometimes people use this notation, x1 to say number of successes in group 1 and x2 number of successes in group 2 over n1 plus n2. Okay, so that's this p, this common proportion, because the null says they're the same, so we're lumping them together to estimate that same proportion. Then we're almost done. You're saying we have almost no more room, no problem. If you remember the next steps, 3 was find the p-value, what's the probability of observing this kind of test statistic, interpreting that and stating our conclusions. All those are going to be exactly the same as one proportion. So I'm just going to say steps 3 through 5 are the same. Thank goodness. Okay. All right, the next video we'll kind of apply some of these things to an example so you can see how the numbers get plugged in.